Hello. So we are back Tuesday, and we have a job. We have a motherboard job. I think it's motherboard. It can be the charging port, but we don't know yet. So we have the charger. Let me start my multimeter. In January is the weird month, only boring jobs. Only I don't know, but it's the most boring month. January. Probably even February will be rough, or will be the same. So the charger, we have the charger 19 volts. Plug the charger. I can't see any light like LED. This doesn't have LEDs. No, so are no LEDs here. Press the power, nothing happened. There's no working, it's not coming on, it's just dead. But the interesting part has no LED on any side, are no LEDs. Or maybe here. I think here can be, but we don't know. So let's open this and fix it. Okay, this is spinning, so probably the plastic is broken. Poor quality laptops. This is an Asus model X540N. Let's see if we can fix this. It's pretty cold. It was like -4 in the morning. Cold weather. One more. Yeah, that's it. Let's open the laptop. Plastic clips. Okay, we have a few cables here. This is a new one, so probably with the internal battery, probably we have a frozen BIOS. Let's see the charging port. Charging port, multimeter. Minus, plus. No, 19.3, so the charging port is fine. So let's try to remove the... We have a seal here on the screw. Let's try and remove the battery. Yeah, I have to remove this and this. Yeah, crazy design. Okay, so we remove the battery. I don't think we have a BIOS battery here. Plug the battery back. Plug the charger back, and still we don't have the charging light. So here we have two LEDs. So this is still dead. Okay, that's good. That's good. Let's see, do we have 3.3 on the keyboard connector? Because the power button is on the keyboard. Dead, nothing. Okay. Let's follow the 19 volts. That's the fan. Can be a digital fan. So what do we check first? Our main power L, which I have no idea where it is. We have no schematic. I can see here a MOSFET, which is most likely is related with something. I have no idea. We have 3 volts on this side and nothing on the other side, so I have no idea what that MOSFET is doing. We have here 2 more MOSFETs. Nothing. We have the capacitors here, still nothing. So starting from the charging port, is nothing here, so everything is on the other side of the board, so we have to take out the board. But should be a charging light there, and it's not. I want to take the battery out, and after that the screen connector. Okay, that's good. I have one more screw here. And the board is out. Now this is a nice board. This is a nice one. It's nice because you can follow the things, yeah? You can see the charging port coming, the plus to this resistor, first MOSFET, the second MOSFET, and we have the current resistor here. And you see, it's not. This is a nice board. You have the E&E chip, which is the startup chip, the processor, RAM memory. You have the power supplies. Look, like coil, MOSFETs, capacitors, input capacitor, output capacitor. It's nice. It's nice when you can follow the things, so you can recognize. So it goes, oh, that's a power supply, yeah, that's a power supply, that's the input, that's the first 2 MOSFETs, the current sensor, and it's going to this capacitor, and after that it's going to all these power supplies. Easy to be followed. Easy to be followed doesn't mean easy to be fixed. Whatever will be there. Okay? So we have the charging port on the board. We can just plug the charger and follow the things. Yeah? Let's come with the microscope. The CCTV died, okay. So we have the charging port. That's a nice charging port. Okay, so you can see the plus. Actually, the plus is going on the other side of the board here. So the truck is going on the other side of the board. Okay, so the plus is coming to these resistors, yeah, carbon resistors, and after that is going back to the other side of the board. But also, it's a small truck going on a resistor, which probably this is checking the input. Yeah, that's why you cannot come with the power supply on your main power rail like here. Where is the current sensor? Like here. So first MOSFET, second MOSFET, current sensor. Yeah, you cannot come with power supply here and expect the board to come on. No, it will not work like that because it's checking the input. Yeah. So one more time, what we said? We said we have this track is going here on the other side of the board, which is probably here. Yeah. So that's our first MOSFET, the output of the first MOSFET going on the second MOSFET. This is a channel N MOSFET. The gate is here. This is a channel P MOSFET. It's simple, it's just a simple thing. So the charger is plugged in. Let's check some voltages. On the charger we have 19.3, you can see on the multimeter. First MOSFET input. First MOSFET input 19.3. First MOSFET output 3.1. And obviously on the second, after the second one, and the current resistor will be the same, 3.1. So from some reason this MOSFET is not open or is not close. Depends. Some people use open or close. Some open, some close. So from my point of view, this MOSFET is not open to just leave the current to flow. Or if you see the MOSFET like a switch, it's not closed, so you don't have a closed switch. Anyway, this is not driving the current, or it is driving, but on the other side I have 3 volts, 3.1, which is not enough. This should work with 19. On the gate we have 3.1. So the MOSFET is doing exactly what the gate is telling him. So the MOSFET is fine. Okay, nothing wrong with the MOSFET. The input, we have a capacitor here, which is fine. We have a resistor, and we have a track is going somewhere, and this resistor. Let's check before this resistor. 3.1, same. So it's going on the other side of the board. It's going where? It's going here somewhere. You think we can find the fault without shorting the MOSFET? Huh? Let's try. We have 19 here. You can see on the multimeter. So this is a resistor. It's doing 4.5. Okay. Where is our track? Our 3.1 track. No, it's not here. Where is my track? It's not here. .3.1. So my track is here. So this transistor is outputting on the gate of that MOSFET, yeah, 3.1. Let's see what we have on the input of this transistor, whatever it is. We have nothing. Okay, if you have nothing here, that doesn't mean the transistor is not working. Maybe it's meant, yeah, maybe it's meant. Let's say this is ground, and this is the base or the gate. Maybe it's in case of something wrong happen somewhere, something. It's bringing here some voltage, and the transistor will short to ground the gate. That's a very simple protection. Okay. Okay, so I know the other MOSFET gate is going in two places, not only one. So I have to find the second one. This is 3.6. I'm just looking for 3.1 phase. You know how can I look? 1 second. Actually, I can't. No, I can't. Because it's a resistor there. So I don't know where that. This is 3.1 again. How this can be 3.1 if it's going to ground? Or this is not ground? No, that's not ground. Okay. Good. Let's check our main power rail. Let's get the power supply, 19 volts. Great. Let's see if we have no short. Because it will be stupid if we have a short on our main power rail and we are looking for something else. Yeah, so I'll call my 19 volts here. And it's no short. Actually, it's the board is starting. Or is trying to start. Tell me 120, 400 and it's going to 0. Okay. So our main 19 volts power rail is not shorted. You see, this is an interesting case. So what is the reason why that MOSFET is not working? Because the MOSFET is good. So one more time. On the gate we have 3.1 and the gate is coming to this resistor, is going here and is going here, so we have two dots there on the other side of the board. The other side of the board is like here. Somewhere here are two dots. This and this can be. Can be these two. Let me check one more time. So one more time. If these are the two dots, so here is 19, here should be 3.1. Sorry, 3.1. Yeah. So here is nothing. Maybe these two. Yeah, these two. So this is 3.1 here. And the second one is not here. Is here 3.1. So these dots are from the other side. So 3.1 is coming here. And here we have 0.7. So our track is not going here. or it's confusing. It's confusing because I don't get it how here I have 3.1. Maybe even this dot is going somewhere. Let's see what voltage we have on this one and what this is doing. 4.5, 4.5, 4.5. Here is 0. And here is 0. I think this is meant to work with 19, not 4.5. Okay, let's have a closer look on this circuit. So here you have 19, and here you have 3.6. I don't think that's good. So 3.6, and obviously on this chip is going here. Is going nothing. 3.6. This is a nice power management circuit without any chip, which looks simple. But it's not so simple. Okay, give me 1 second. Because I have to check to be sure where that track is going. So the track from the gate of the MOSFET. We just need to be sure. The track here. Here I'll do the second resistor. The second resistor. So once it's coming to the second resistor here. Here. And the second track, because we have a track after our resistor. Give me 1 second. Yeah. And the second track is going I don't know where it's going. I don't know where it's going. So the second truck, so I found this truck, exactly the gate, but not this one. I don't know where this is going. I can't find that truck here. Okay. Okay. You see when actually the board is asking for for help. You know, the board is screaming, "Help me, help me." I tried. Now let's help the board. How I know to do it? The easy way. So the MOSFET is removed. The solder iron is not hot yet. Perfect. So we have a nice bridge with solder. Okay. Can be dodgy. Well, let's check, see if it's working. Plug the charger. Let's see if we have our 19 volts power rail. So checking on the same current sensor, we have 19. So I did try to find the problem. It's hard without schematics. It's hard to diagnose a fault like this, because obviously you have to see from where the signal is coming, where it's going. You have some condition there which must be, you know, so it can be tricky. It's more easy just to modify the circuit. And okay, there is no 19, just let's bring 19. Obviously we took some precautions, so we check with the power supply if the power rail is not shorted, so it's safe. So I'm not saying that's the way how you should fix the laptops, but what about if you don't have schematics, you don't have time, but obviously you want to get the job done? Okay, let's plug the charger now. Charger is plugged in, and we have the charging light, we have the power on light. And we have picture on screen. You can see. Now I read the comments before. I think on the last video when I done same thing, short in the MOSFET. And the people, some comments was okay, the laptop will not charge anymore. And this is very wrong because the main power rail is that your main power rail, you know. It's we short a switch. It's a MOSFET, but basically it's a switch. It's not regulating the voltage, it's not doing anything else apart from being a switch. Okay? But like how I said, it's better to take your time and fix it properly if you have a schematic, obviously. If without schematics, probably I can spend a few hours and I'll find the problem finally. Because you put on the paper and you draw the schematics, that resistor and it's going to that thing, and at some point you will figure out the fault. More or less, okay? So the laptop is fine. We can plug the keyboard. There's not even a point, but we can try with the keyboard. I'll put all the screws and everything, I'll put it back. Let's try and power off the laptop. It is switching off or on. We have picture and it's loading up the Windows. Okay, the laptop is fixed. It's just, you know, it's okay. I have to put this back. It's just we have only boring jobs, and that's the best what I can come with. Yeah, but don't worry, I'll try to find something else. Anyway, thank you for watching. Like and subscribe if you like the video. And see you on the next one. I think I have something more. Yeah. Okay? Bye. And my mouse is not working.